Question 11. So for part A, how many square tiles are needed to make pattern number 6? So let's consider the number of squares. We've gone from 1 to 4 to 3. Or, if you like, 1 squared to 2 squared, that's 2 by 2, to 3 squared, 3 by 3. So following that pattern, the fourth pattern would be 4 squared, fifth pattern 5 squared, sixth pattern 6 squared. 6 squared means 6 times 6, which is 36. Now, let's now look for part B at the number of circular tiles needed to make pattern number 20. So let's just try and establish a pattern for the circles. Well, we've got 4 first of all, then 8, then 12, and we've got to try and see what's going on. How do we get from its term number, where it is in the position? This is the first term, second term, third term. If you like, n equals 1, n equals 2, n equals 3. How do we get from the position to the number itself? Well, can you see we're multiplying by 4? 1 times 4 is 4, 2 4s are 8. So our 20th term, the one in the 20th position, following the same rule, the actual number itself is going to be 4 lots of 20, which is 80. Now for part C, Derek says when the pattern number is odd, an odd number of square tiles is needed to make the pattern. So let's look at the square tiles and the odd ones. So this is the first term, so this is odd, the third one would be odd, fifth would be odd. So how many tiles have we got here? Well, that's 1 squared. How many tiles have we got here? We've got 3 squared. Okay. Now what we notice is we're doing that we've done an odd times an odd to get an odd. Done an odd times an odd to get an odd. Well, our fifth term would be 5 times 5, odd times odd, to get 25, which is odd. So Derek is right, because all odd numbers squared will always be odd, because odd times odd equals odd.